The thing about this is that the forecast shows us in between the systems, or going from one system to another, and this is always where forecasts get a little bit iffy, shall we say. So to start off with this, I mean, looking at the isobars, we've got our isobars whizzing around the high pressure system like that. And as always, if you're trying to work out what direction the wind is going to go on the surface, basically, if you draw an arrow across your isobar from the high pressure side to the low pressure side at about an angle of about 15 degrees, that's pretty good for your wind direction on the water. Now, it's a high pressure system, so you'd expect a lovely day, lots of sunshine, not much cloud. And that was the forecast. It was forecast to be somewhere in the mid-20s on the water and nice and sunny. However, in the wings, coming in from the Atlantic, off from the west there, you can see there's a low pressure system with lots of fronts, and these black lines there are troughs, which are basically just lines of squally activity. So as this comes in, what we'd expect at some stage, when that comes in, is for the weather to change from being a nice, shiny, sunny, high pressure driven day to being a bit more unstable, more low pressure driven. So there's fronts coming in, you'd expect some clouds at some stage. And the wind was going to forecast to veer all the way around to southwest, west, and eventually west northwest. So that's the big picture on the forecast. You start off with a nice sunny easterly, east southeasterly, then a whole bunch of change in the middle, coming back in from southwest, veering further to the west later on. That's the overall picture. Now, let's have a look now at what the weather models were telling us for that day. Now, the Round the Island race has been supported the last few years by FAIR. I have no idea if I'm pronouncing that correctly, but they do a very good high resolution model at 8,000ths of a degree resolution, which in real terms equates to a forecast grid of just under 900 meters. And on the screen now, you can see their forecast for 0900. That's British summertime, so local time, with a little wind arrow. So you can see the density of the forecast data as it were there. And what we have here is a nice little, as we expected from the synoptic chart, easterly, east-southeasterly. And I know I haven't got a scale on here, but the forecast there is about 12 knots. So lovely day, really. And actually, for around the island start, what could be more fun than having a spinnaker up with 1,200 other boats on the start line? What could possibly go wrong, I ask you? So anyway, so later through the morning, not that much change. This is now the forecast for midday. Hardly any change at all. Maybe it's a little bit veered, but nothing too dramatic. It's in the afternoon that the forecast looks to be the change between systems looks to be coming in. You've got over here, you've got your 12-knot easterly, southeasterly, but then coming in past Portland and eventually Anvil Point towards the Isle of Wight, you've got the wind veering and easing off. The blue on my scale there is about 5 or 6 knots. As the high pressure moves away and the low pressure comes in. And it's around about 5 o'clock on the forecast from the previous day that we're expecting the big change to come in here with our southeasterly, east-southeasterly wind being pushed really past Chichester and coming in from the west southerly and then veering further to the right after that. So as that moves through, you can see just the difference. That was 1700. If we go through an hour, you can see there's a big change all around the bottom right-hand quadrant, the southeast quadrant of the Isle of Wight there. So the conditions through there and through the Western Solent are changing dramatically in the forecast anyway, from the late afternoon through to early evening. And then as the evening carries on, then the influence of the low should build, and we should get this nice moderate west-southwest to pretty much west or west-northwest at the end. So that's the model. That's the model forecast. And the interesting bit on it, the bit where as a sailor you're going to be thinking, oh God, put a bit of thought into this bit, is the bit of the change in between the systems to see what it actually looks like on the water. And how can we think about this? So let's have a quick look at that. And that's really what I'm going to talk about, how to think about the twiddly bits as that forecast changes. So always a good thing to have a look at what actually happened compared to what the forecast said. So it's a bit of a busy chart, this, but I think it's quite useful. The dotted the more squiggly lines, excuse me, are the actual readings from the weather station at Chichester Bar, which were supplied, thank you very much, by the Solar Support Group, who run that particular organisation. They also do BrambleNet and all that lot. So we've got I've got the wind speed is in blue, with the scale on the right hand side there, and the wind direction is in orange, with the scale on the left hand side. So in the morning through to the early afternoon and actually almost evening, you can see we've still got this east-southeasterly all the way up to 1900, and over at Chichester anyway, which is more exposed to the east, obviously. So you'd have about 12 to 16 knots, so quite nice out in the eastern Solent to there. And at that point, after 7 o'clock, you can see what happened is everything went really floppy, which is a technical meteorological term, obviously. The wind direction went all over the shop, another technical term, before finally settling in 2-3 hours later at our expected west-southwest. The wind speed as well dropped all the way down to actually zero for a little while before coming back up again. And if we compare that to the actual forecast, the forecast covers that not too badly, actually. The big difference in the forecast to the actual is that the forecast had it coming in about 2-3 hours earlier. But as far as the actual numbers go, it's looking pretty good. If you compare the direction there, which is the smoother once an hour curve, with the actual direction, pretty good. If you look at the forecast wind speed, they were forecasting about 12 knots, so maybe a couple of knots low on the mean. But actually, the whole change overall in the wind speed and direction was forecast pretty well. So good quality forecast there. And this does highlight that if you're looking at something, if you're looking and doing a bit of planning the night before, which you would be, I hope you would be for an event like this, all you have to work with are forecasts which are 24 hours, which are at least 24 hours into the future. So this illustrates nicely the fact that with weather forecasts these days, the what of the forecast normally works. The thing that what normally has the most room for error in it is the exact timing of things, especially quite tricky changes like this, changes between systems. So again, right, so that's what actually happened, reasonably on forecast, just it happened a little bit later than the actual forecast. So let's have a look at a few of the tricky bits. So the first bit I'm going to look at is St. Catherine's Point there. And then the second bit we're going to look at is the whole southeast quadrant of the Isle of Wight, especially on a nice changeable low wind strength day. So what was going to happen, what the forecast was the previous day, was that up until about 1400, excuse me, we should have a reasonably good east-southeast, about 10 to 14 knots, with tide ebbing around St. Cat's like that. By the tide itself turned at around 1400, 1430. Excuse me, the wind should have still been there, but then by about 1600, 1700, the tide would have been flooding around St. Cat's, but the wind itself would have been moving around from east-southeast all the way around further right to southwest or further than that. So really unsteady and really unstable. Excuse me, and only really settling in back from the southwest or the west-southwest by about 1900. So that was the forecast. Let's have a look at what happened at St. Catherine's Point even a little bit earlier in the day. So this is the forecast for 1300, when really a lot of the fleet would have been actually going around St. Cat's, round about here, or maybe just about to come around St. Cat's. The wind arrows are the little green jobs, so you're still looking at about 12 knots on the forecast, and the tide, which I got from Graham Sunderland's excellent Winning Tides book, is you can see it's ebbing strongly through the deep channel there. That 0.33 there by St. Cat's Point itself, that's actually a lighter tide inshore, and you can see that inshore in Freshwater Bay, excuse me, the tide is just starting to turn to flood. So we have this eddy starting inside there. So anyway, that's what the forecast gives us. Great. What we need to do now is have a think about what happens beneath the forecast. And this is a really important point to understand about modern day forecasting, is that because it's numerical weather predictions, it's all done with numbers, and it's all done on a grid. In this case, quite a high resolution grid, around about 900 meters in between each grid point. But still, if you're trying to model anything numerically, pretty much the smallest thing you can actually model is about 4 times the size of your grid. So even with a high resolution forecast like this, even with a good quality high resolution forecast like our Fair forecast, you're not going to catch all the tiny little detail which is useful as a sailor. And you may be thinking, well, why do I need tiny little detail? I'm a sailor, for God's sake. But as a sailor, you deal with tiny detail all the time. And if you think of it, when you're trimming your mainsail, you'll look up excuse me, you look up the leech, and you'll pay attention to each of the individual telltales going along it, and you'll play with the controls, the outall, the travel of the sheet, to make sure all those telltales are flying nicely. So as a sailor, you're used to looking at really high resolution wind effects, and it's important to do so on the water as well. And as a sailor, what you should be trying to do with a forecast, we've got a forecast like this. It's a moderate easterly going past a headland. If we try and look at that in a bit more detail, and this is what I call thinking subgrid. What's actually going to happen in reality is we're going to have acceleration around there, because all the wind that's trying to come in from the east there, not all of it will be able to go over St. Catherine's. A lot of it will have to be squeezed round it like that, and that will give us an acceleration zone inshore there. Excuse me, especially, and also another good reason to go inshore there is because the tide is so much less inshore than it is in the deep channel there. And if you look at what actually happened on the water, there's people doing exactly that on the day. They're tacking close inshore, trying to get a little bit more wind and staying out of the strong tide. And that's the first really, I think, quite important subgrid moment in this forecast, because things like that just aren't forecast by the numerical models just because they're too small. They're too small a feature to actually be modeled numerically with the computing power we have at the moment. Right, so that's going around St. Cat's. If we then look further on, both in space and in time, this is now, I've got the forecast here for for 5 o'clock in the evening, and we're now looking at excuse me, the run up to basically Bembridge Ledge here. Now, looking at this, if we look at the wind first of all, further offshore here, the wind's it's veered quite a lot already. It's now on the forecast anyway. It's southeasterly, and it's also dying off. The wind out there was forecast to be about 8 to 10 knots. The wind in here, this dark blue, is forecast to be about 3 to 4 knots. And also you can see that the tide is strongly flooding now, and it's an awful lot stronger slightly offshore than it is slightly inshore. So from a forecast point of view, it looks here, well, okay, I could if I take the direct route going in between, going a squeeze round past Ventnor off down to Bembridge there, then I'll probably have a knot less tide than if I go outside there. But it's slightly shorter, so maybe it's worth it. The thing is, though, if you put your sailor's head on again and you think beneath the forecast, let's try and have a think about what's going on, the effect of the island itself, because I know the island is downwind of you, but it still has an effect on what's going on. And I just want to look at the difference between the land and the sea temperatures during that day. Now, the blue curve here is the seawater temperature at Chichester Bar. So not necessarily, it's probably a degree or so more than the water off the Isle of Wight in the main channel, just because it's probably shallower there and it's a little bit close to the land, but it's representative. And the red curve there is that's the temperature data taken from a land station just inshore in Sandown itself. So so close to the water, but on land. And you can see the massive difference in temperature, especially in the early evening, from land to sea. In fact, bizarrely enough, This was actually in town. This weather station is somewhere actually in the middle of Sandown itself. And it must have been a particularly airless part, because you can see it gets up to just over 30 degrees Celsius just before 8 o'clock at night, which is a bit bizarre if you think of Sandown. It's not really known for being a tropical paradise. But anyway, the point is, the point I'm making here is that the land temperature is significantly more than the sea temperature. And what that means is that the boundary layer, which is deeper over land than it is over sea, and this is quite important, because the boundary layer is the bit of the air which is directly affected by the surface, by surface heat and by surface friction. It's the bit that we sail in, and it's quite turbulent. We've all seen, even on nice high pressure days, you still often do get little patches of gusts, even if there's no clouds around, and that's because the boundary layer has air rising up from the surface and effectively just bouncing along inside it. Some regimes are less bouncy than others, but that's basically what happens. So on this particular day, if we think of the air coming in from the channel, because remember it's just a little bit south of east, the wind, it's going above 22, 23 degrees Celsius water. So there'll be warmer air bubbling up from there. So there'll be a little bit of a turbulence as this east southeasterly wind rolls in. Then as it gets over the island, there's a couple of things going on. First of all, it has to physically rise up over the island, because the island's the island, and as you can see from this photo looking down around Sandown, there's Sandown Bay towards the northeast there. There's actually some quite big cliffs there. So you've got that as well. The air has to rise up over there, but also the air temperature above the land is much higher anyway, because the surface itself is much warmer. Now that weather station which I put up on the last slide, that was in an urban environment, so it's going to be a bit warmer than in the countryside, but still there's going to be a good 3 or 4 degrees higher surface air temperature over the island than there is over the water, and that's going to make that boundary layer deeper, because there's more stuff basically bubbling up from the surface. So the effect this has on wind coming off the sea onto the land, effectively your wind will start to do two things. It'll start to the main flow will start to lift up off the surface, and also there'll be much more vertical movement inside that boundary layer. There'll be much more. You'll get much more an effect of air coming down and hitting the surface and popping out in sort of cat's paw gusts like that. Also, you'll get more air just rising vertically, which if you're trying to sail through, there's useless, because sailing depends on horizontal air movement. So basically, what happens on days like this, on a nice hot day with a moderate onshore breeze, is that the area closest into shore will become much more patchy and much more shifty. And so if we go back to our chart, here, going around here, even before you get there and start looking under your Mark 1 eyeball and your sailor's knowledge, it makes sense here to start to plan to go a little bit further offshore, to stay in the stronger tide, which will give you more sailing wind anyway, and also should keep you out of what is going to be very patchy and very messy wind close in there. So even though that's the shortest route, the actual nature of the wind in there will be very patchy, very shifty. Excuse me. And if you stay out here, it's still going to be patchy and shifty, but it's not going to be as patchy and shifty. So that's that section of the island done. Excuse me. Now having a look around at all of you on my screen here, no one's actually asleep. So well done. Anyone got any questions so far? Nah, good, excellent.
Simon, it took me a moment to unmute there. I'm sorry. I just wanted to say how exciting this is, because I'd have just said, "Oh, that temperature difference, sea breeze, be great to be inland."
Interesting question, and well done for bringing up that point, because you're right. It's going to try and make a sea breeze, and if it was an offshore gradient wind, if we started off with a northwesterly or a northerly, possibly that would have happened. But for a sea breeze cell to generate, what's going to have to happen is that the air above the island is going to have to go out to sea and start and basically work against the incoming gradient wind. So that is going to try and happen, because as you quite rightly say, there's enough temperature difference there if the gradient wind direction was correct for a sea breeze cell to set up. But in effect, what that's going to do is just add to the carnage and the chaos and the puffiness and the patches. So yeah, very good point. It's going to try and happen, but because of the direction of the gradient driven wind, it won't. But what it will do is mess things up even more. So if we now look at the eastern Solent, so you've managed to get around Bembridge Ledge, and it's now a little bit later on. You're looking, hopefully, by if things are going well, hopefully you're around there, say 17, 18, 1900, something like that. So let's have a look at what's going on as per the forecast from the previous day in the eastern Solent. So we've got our east southeasterly wind, which will actually be quite nice. And as you saw from the wind trace from Chichester Bar earlier on, which is obviously a little bit off screen, but much in the direct line there was a good steady wind direction. It was ever so gradually varying, but hardly any. And the wind speed was fairly steady between about 10 and 14 knots. So really lovely. So anyway, excuse me. So this is now. Where are we? Sorry, I've got ahead of myself. Yeah. So up until about 1300, the tide is ebbing. Then the tide will change then, and it'll flood. I'll put a bit more detail on this in a moment. But it'll flood until about 8 o'clock in the evening. Now, by about 1600, the wind was forecast to be going to be veering right. So this will now be veering right in the channel, but it'll have to make its way over the island and then through the Western Solent. It'll carry on doing that till about 17, 18, 19, 2000, so till about 8 o'clock in the evening, when it should start to settle in from a little bit south of west, and then carry on veering a little bit further to west later on. So, the around the island race is never supposed to be easy. And this is a classic example. So, what do you do with this? Do you go inshore? Do you go offshore? How do you play this? So, let's have a little bit of a look at what goes on now at 8 o'clock in the evening, because it was a fairly light wind day. There were an awful lot of people in the Western Solent at 8 o'clock in the evening. In fact, I suspect there's quite a few people listening in now who are doing just that, not drifting up sorry, I said Western Solent, I meant Eastern Solent, but hopefully you've gone farther than the Western Solent by 8 o'clock in the evening. Otherwise, there's real trouble here. So what we have now is, if we look at the wind, which is the little arrows there, it's the forecast says it's coming from the west-southwest, but not particularly strongly. I mean, what we forecast there is about maybe 6 to 8 knots, so nothing dramatic at all. And the tide, again, this is from Graham's excellent Winning Tides. It's the last of the ebb up by Cowes, sorry, the flood, last of the flood by Cowes, and you've got the first of the ebb just coming in through the Eastern Solent there, and there's a bit more inshore than there is offshore there. So, and if we just go forward an hour, that effect is even more pronounced. So you've got quite a lot of tide inshore, and still very little over on the northern side of the Solent, and the wind is just it's gradually coming in, but nothing too dramatic. So what do you do? Well, the good thing, the great thing in this case is you've got wind over tide, which may sound a bit stupid, because of course we also know every one of us who's done a bit of instructing always says, well, wind over tide is terribly dangerous. But in light wind situations, wind over tide is excellent, because it basically pushes you into the wind, and will give you another knot or so, depending on how strong the tide is, of actual sailing wind that you can actually use. And you can use it whether you're going upwind or downwind, but it's much better to use it if you're going upwind, because you're obviously going into it. So that then you can take your increased sailing wind, and that will give you even more of an increase in your apparent wind. In this case, looking at the forecast the previous night and thinking, well, what am I going to do if we're popping around into the Eastern Solent when this is all happening? What I would look at this, I'd say, well, where are we actually going to get more wind? We're probably going to get more wind in total inshore there. It's a bit of a toss-up, you see, because it's a bit cooler. 8 o'clock in the 8 o'clock in the evening, things should be cooling down a bit. So even though the wind is having to come all the way over the Isle of Wight, because the land will be cooling down, that boundary layer should be a little bit shallower. So there should be more mixing going on, bringing the slightly stronger wind from above down to surface. So hopefully we should actually have more wind, slightly more wind, probably on the in the middle of the Solent than inshore there. However, there's an absolute natural tide in the middle of the Solent there, where there is actually quite a lot more here. You've got about half a knot of tide there, and about 0.2 of a knot of tide there. And I know that doesn't sound very much, but if you think about it, when you're light wind sailing, there's a big difference in the amount of power in your sails from, say, 4 knots to 4.5 knots of breeze. I know it may sound silly, but even on quite heavy boats, and I have a lot of experience on quite heavy boats. If you get things set up nicely and you get the crew on the leeward rail and all that good stuff, then you can actually make reasonable progress. So if I was looking at this the night before, I'd be thinking, right, I'm definitely going to go inshore there. Apart from anything else, if I tack inshore, then with this forecast wind angle, then the offshore tack will give me a reasonable heading up the Solent, and at that point I can be looking around with my head out the boat and having a look to physically see where there's more wind on the water. But for my planning the previous night, what I would be thinking of is I'll go inshore there and see what happens. And that is just as time goes on, that effect actually gets even more until basically the entire Eastern Solent is one big ebb tide, which then it's easier to go anywhere you want. You have more options open to you. Excuse me. There's also a big thing with the wind coming off the land. Whenever you have wind coming off the land, it's almost always both unsteady and unstable. Now, it's not an official term, this, but there's the way I like to think of it. I think of unsteady wind as being wind which doesn't have a particularly good mean. So if your wind is, if you've got, say, if it's gradually veering, or if it's flicking left and right without a particular steady mean, then that's unsteady wind. Unstable wind for me is wind which has lots of gusts and puffs in it, so lots of patchy wind, because instability for me is more of a vertical thing, more of a vertical mixing thing. So with your wind coming offshore like this, it's probably going to be a bit unsteady and quite unstable. And if we have a look at the wind traces from the Brambles Bank here, this shows us quite nicely. I know the Brambles Bank is wind station is further in the middle of the Solent, but it's reasonably good. If we look at what happened in the morning, when basically we had the wind just coming up the Eastern Solent there, yeah, it is a bit of up and down, but in every hour, there's not that much of a difference between top whack and bottom whack, between your minimum wind speed and your maximum wind speed. So that's reasonably steady. There's not that much change in direction, and it's fairly stable. There's nothing too dramatic going up and down. But when we have the winds coming, when the wind changes round, it does so quite quickly here. It basically stops. It stops coming up the Eastern Solent, and then about a couple of hours later, it starts coming up the Western Solent. We can see that the wind direction is fairly steady, but if you look at the wind speed there, it's all over the place. It's really unstable. From a lull of 4 knots, a mere 30 minutes after a peak of 16, for example. That's really, really unstable weather, unstable wind. Sorry. And this is what's going to be happening in the Eastern Solent. It's going to be quite puffy and quite gusty as the wind rolls off the island. Now, as things cool down, that will get better. But it still means that whatever's actually happening on the water, what you can say for sure is you really need to be paying attention to the trim, to where the patches of water are, to make sure that you're making the best out of it. And there's also one thing which I haven't really spent any time on so far, and that's talking about the visual clues that you'll get with the changing of the systems, because we did mention briefly at the beginning of this that the overall weather for the day is changing from a high pressure driven system and becoming a low pressure driven weather day. So if we think about what's happening with the clouds, with your high pressure, there's not that many clouds generally at all, and it was beautiful sunny morning and beautiful sunny most of the afternoon. But with the low pressure system coming in, what happened was that you started getting lots of high puffy of high cirrus clouds, and then later on in the afternoon, as the wind actually started to make it down into the Eastern Solent, you had these little puffs of altocumulus, just little puffy stuff coming over the island there. And this was actually done. This was used really well by these guys. It was the Greek City Academy e-boat. They were I think the youngest crew going around the island that day. That was Isaac, Sale, and Samuel, they had studied their forecast the night before, and we knew that the southwesterly was going to come in. We just weren't sure when. But what we did know was that because it was a low pressure system, the clouds would come in. And what happened was around about Benbridge Ledge, they were given the opportunity to retire by John Holt. I'm sure all of you are familiar with John. He said, "Well, look, there's no wind. Everyone's bobbing around," and they pointed out because you could just start to see clouds going over there. They said, "No, westerly's on the way." And it was. And they sadly didn't quite make it to the finish line in time. They crossed the finish line, I think it was 12 minutes after it shut. But they finished. They finished themselves, and they did really well. And the good story that came out of that was that Ross Appleby of Scarlet Oyster fame was in the boat behind them. He was in a folk boat, and he was really impressed by that. And their helmsman Selen actually then got taken across the Atlantic on the Ark that year, and did loads more sailing out in the Caribbean. Is a direct result of the guys understanding the weather and knowing that because they could see physical signs coming in, that the new wind was on the way. So I guess really to sum all this up, first of all, have a look at the overall synoptic situation. See what type of weather you've got. Is it high pressure driven? Is it low pressure driven? Is it going to be changing, or are the isobars basically the same direction all day? So if the isobar is the same direction, the same width apart all day, well, what you get at the start is bar a bit of surface heating is going to be what you get at the end, or is everything changing in between? And once you've had a look at that, then try and think from there what will you actually see on the water. Especially with changeable systems, have a think about how the models are going to handle this, and just always bear in mind that whenever you're looking at a forecast, is that however detailed the forecast looks and however detailed the forecast says it is, you can get forecasts which call themselves super forecasts, and they're in color, and you have to pay for them, so they must be good. They're only the smallest detail they can see is about 4 times the size of the grid. So even with generally the stuff you can get for free off the web has or for not very much money off the web, has a resolution of about 1 kilometer. So the smallest thing that it really cares about is 4 kilometers wide. So if you have a little island which is less than 4 kilometers wide, it's not going to exist. It's not even going to exist in the model. If you have a weather effect that's less than 4 kilometers wide, and if you think of the acceleration zone around St. Cat's, for example, that's way less than 4 kilometers wide. That's not even going to exist in the model. And that's not a criticism of high resolution modeling. It's just a fact of it. So have a think about that, and have a think about what's not going to be handled well. And basically, the more land there is, the worse the model is going to perform on the for sailing nitty-gritty. Then have a think about what you're going to see during the day, as in physically see, as in cloud formations. Are you going to get a difference in atmospheric temperature, for example? If you're expecting a katabatic wind to come off high ground later on potentially, then one of the things you should be a little bit wary of is if things start to get cooler quite quickly. That type of thing. It's not only the visual; it's anything that your senses can pick up. If it's a pressure system coming in, can your barometer tell you anything? Are you looking for the barometer to rise up, plateau, and then start coming down, or something like that? Whatever it may be. And if you put those physical signs, for those visual and physical clues into a sequence for yourself, then that's what you should use to show how the weather is progressing, rather than saying at 3 o'clock it should be southwest, at 4 o'clock it should be west. Because, as I mentioned a couple of times, the timing of the forecasts, especially if the forecast is for about 24 hours ahead or more, that's what's going to go awry. Whereas the what of the forecast is generally okay these days. And really important, whatever boat you're sailing, however high tech it is, and if you look at what's happening in New Zealand these days, it's still so important to keep your head out of the boat and to look at where the weather is and to look at what's happening around you, both to leeward and to windward. And the more you do that, the more efficient your sailing will be. Well, that's pretty much it. So I've only got one last thing to do, and that's to have a blatant plug for my new book. So there you go, blatant plug on the screen. Excellent. Well, that seems to be it then. And please, questions. Anyone got any questions, comments, abuse? Ask away.